Hello guys, my name is Ritvik and in this video we are going to talk about the hypothesis. So basically, hypothesis is a statistical concept. With the help of this concept, you can identify the relation. You can identify that a particular thing is true or not, right? So this concept we can use in a feature selection part. Feature selection part. So basically, what we do in a feature selection part in a feature selection part is we identify the relationship between the dependent variable and dependent variable. So at that time, we need to identify the relationship between the independent variable and dependent variable. Hypothesis testing is so much useful in this concept, so that's why we are learning this concept here. Okay, so now the question is that is the feature selection concept feature selection part in data science is much more important than any other concept? Then I must say that yes, because in the feature selection part, sorry, in a machine learning problem, when we are working with a machine learning problem, at that time we might have many columns, right? Many columns, probably there are n number of columns, and then this n might be 300 or 200 or any number, right? So we cannot create our ml model on this kind of columns, right? Because as much as less column we have, as much as less column we have or less dimensions, let me say less dimensions we have, our model will be very accurate on less columns. Accurate. So we try to remove most of the columns from the data set. Most of the column from the data set. And definitely there will be a problem of data losing, right? But we will discuss about this problem in my upcoming videos. So basically, hypothesis testing is mainly used for the feature selection part, right? So in the hypothesis, we have two type of hypothesis. First of all, null hypothesis, and the second we have is alternate hypothesis. Alternate hypothesis. Null hypothesis you can represent like h0, and this one is represented by h1. So null hypothesis, so let me discuss about the null hypothesis first. Just hold on. Okay, so null hypothesis we can use. So null hypothesis here. Okay, so you can use null hypothesis when you have an assumption, yeah, right? So suppose you want to identify the relation, right? And you made an assumption that there isn't any relationship. There isn't any relationship. Suppose you have two variables a and b, where a is working as a independent variable, dependent, where second one is the dependent variable, right? And you want to identify the relationship between these two continuous random variable, right? So you made an assumption, and that assumption is like this: there is not a relationship between a and b, right? Okay, and you perform some operation on it. There are some statistical techniques like t-test, ANOVA test, and chi-square test, chi-square test, like this many more, right? With the help of these techniques, you will calculate the p-value, right? After the whatever the value here we have, like suppose the p-value that we have counted is nearly 2.85, right? The p-value is here we have counted is 2.85, and we are going to compare with another concept called alpha, because alpha is here a significance value. Probably if you haven't seen my confidence interval video where I've discussed about the alpha, how we can calculate the alpha, and what is a Z table, I've discussed about all this thing in my uh, confidence interval video, and the link is in the description, and also you can check it out from the I button. Okay, so here after the null hypothesis we are going to use one of these techniques as per the problem, and we are going to calculate the p-value. We are going to calculate after the calculating the p-value, if the p-value is greater than 0.05. So now the question is, what is this 0.05, right? So basically, suppose we have a data like this follow the Gaussian distribution. I know my drawing is not good. This is the normal distribution, and we've discussed in normal distribution that this part, right, this part is considered 2.5%, and another this part is considered 2.5%, so that the total is 5%. And here I represent this: if my data is follow in this region, if my value or my data or my relationship is follow in this region, that I'm not going to say that I'm going to say my null hypothesis accepted. Null hypothesis accepted. What does that mean? That means that that my assumption is true. That means there isn't any relationship between, no, isn't any relationship between A and B, right? If the value is like this, P less than 0.05, then I'm going to say that my alternate hypothesis will be true. Alternate hypothesis will be true. Now you might have some question in your mind, is that what does that mean by the alternate hypothesis? So we have made assumption that null hypothesis is like this. Null hypothesis is there isn't any relationship, and when alternate hypothesis is going like this. There is a relationship, right? So if the p-value is less than 0.05, then I'm going to accept this. And if sorry, probably I made a mistake here. If the p-value is greater than 0.05, right? Yeah, if the p-value is greater than 0.05, then I'm going to accept this. And if the p-value is less than 0.05, then I'm going to accept this alternate hypothesis. That means if I have a p-value which is greater than 0.05, then I'm going to say that there is a relationship between A and B. Some relationship between A and B, where if I got alternate hypothesis, that means there isn't any relationship between A and B, and I'm not going to use this independent variable as my input feature in ML model. Variable in my as my input feature in ML model. If there is some relation, right, then I'm going to use this independent variable as input feature. Input feature. So this is all about the null hypothesis.